Hello everybody, thank you for joining me today. I'm going to present you the newest features in Microgateway 4.3. My name is Stefan Dietiker and I am the product manager of Airlock Microgateway. I have quite a few topics that I want to cover. First, the main new features of Microgateway 4.3, some miscellaneous features and changes. Unfortunately, we have some breaking changes I'd like to mention. Finally, an outlook on what is coming next. The new version, Microgateway 4.3, comes with a bunch of new features and improvements. The main new features are own and multi-namespace support, Grafana dashboards, GraphQL schema validation. Besides the main new features, we also made some improvements for OIDC relying party. GraphQL filtering is one of the new features in Microgateway 4.3. But what is GraphQL? On GraphQL's website, it is described as follows. GraphQL is a query language for APIs and a runtime for fulfilling those queries with your existing data. GraphQL provides a complete and understandable description of the data in your API, gives clients the power to ask for exactly what they need and nothing more, makes it easier to evolve APIs over time, and enables powerful developer tools. On the top left corner, we see a GraphQL query sent by the client. Underneath, the corresponding response is visualized. The example shows that apps using GraphQL control the data they get and not the server. Therefore, GraphQL requests are more complex than REST. This means that new attack vectors are introduced by GraphQL, such as special GraphQL requests like introspection and mutation. Requests could lead to high resource consumption. With Microgateway, APIs using GraphQL can be secured by validating the requests against a schema, allow or disallow mutation and introspection requests, filter GraphQL requests with the deny rules, apply limits to GraphQL requests. To configure the corresponding settings, we introduced a new CRD GraphQL and extended the existing CRD deny rules. The GraphQL query is sent in a parameter named query to the server. Technically, it is possible to send the GraphQL query parameter as query parameter or in a JSON body. For GraphQL requests with JSON body, the JSON parser must be enabled. For those requests, JSON and GraphQL limits are applied. To enable GraphQL filtering, simply reference a CR GraphQL in the CR content security. Microgateway 4.3 supports new installation modes. Own namespace, which allows to run the Microgateway operator and the protected workload in the same namespace. Single namespace, which allows to run the Microgateway operator in a dedicated namespace and only watch the protected workload in another namespace. The main difference to own namespace is that the Microgateway operator is deployed in a different namespace than the protected workload. Since these two installation modes are quite similar, the single namespace mode is not explained further in this presentation. Multi-Namespace, which allows to run the microgateway operator in a dedicated namespace and watches a selection of namespaces in which protected workload is running. Please note that the existing modes are only available in the Premium Edition and not possible using the Community Edition. The Community Edition can only use the All Namespace mode, which is the default since Microgateway 4.0. But what are the use cases behind these new installation modes? Using one of these modes allows you to run different microgateway versions in the same Kubernetes cluster. This could be useful to upgrade the microgateway engine sidecar namespace by namespace. Separate tenants or projects from each other, either with different microgateway versions or simply to ensure that tenants or projects cannot interfere each other. Have a self-contained installation mode with own namespace, where the microgateway operator and the protected workload is in the same namespace. This also means that no cluster-scoped airbag is required. Let's have a look how the installation mode own namespace works. As we see in the visualization, the microgateway operator is deployed in the same namespace as the protected web app. The operator is also configured to only watch resources in the same namespace as he is deployed. In this example, it is namespace N1. This is the simplest scenario and shows that everything is contained in the same namespace. Now let's have a look how the installation mode Multi-Namespace works. This installation mode is available in the two options static or dynamic. First, I will explain the static option. The visualization shows that the operator is deployed with a static list of namespaces which should be watched. This results that the operator does only manage engines in the configured namespaces. In our example, this is namespace N1 and N2. The second option is dynamic. The microgateway operator is deployed with a configuration that all namespaces with the configured label should be watched and managed by him. In our case, it's all namespaces with the label managed by microgateway B. That would be the namespace N3 and N4. So this means that the operator evaluates dynamically during runtime which namespaces should be handled or not. Therefore, the namespaces can be labeled or unlabeled during operator's lifetime, and he does track the changes. The following commands show how easy it is to deploy the microgateway operator in these different installation modes. First, I will show you the installation mode own namespace. When starting from scratch, we need to create a namespace where the microgateway and the web application should be deployed. The part in bold deploys the operator in namespace microgateway A, and instructs that he is responsible for this namespace. As a next installation mode, we dive into Multi-Namespace static. The part in bold deploys the operator in the namespace Microgateway B and instructs that he is responsible for a certain list of namespaces. Finally, let's have a look at Multi-Namespace dynamic. The part in bold deploys the operator in the namespace Microgateway C and instructs that he is responsible for all namespaces with the label managed by Microgateway C. After the operator is deployed, we can label our namespaces so that they are watched by the operator. Microgateway 4.3 brings Grafana dashboards to simplify the administrative tasks. We currently provide the following dashboards: Overview dashboard, Block dashboard based on metrics, Block dashboard based on logs. Provisioning the dashboards is as easy as possible. You need to deploy Grafana with Sidecar. This sidecar is part of the Grafana installation and watches for dashboards stored in config maps. Deploy the Microgateway with the Grafana dashboards. By doing so, config maps are created which contains the Grafana dashboards. Simply wait a few seconds and refresh your browser to see the new dashboards in Grafana. The following commands show how easy it is to deploy and use the Grafana dashboards. During the installation of Grafana, simply set the argument in bold to deploy the sidecar as well. For a detailed installation guide of Grafana, please consult their manual. When deploying the Microgateway operator, simply create the dashboards by using the argument in bold. Finally, simply enjoy the dashboards. The following screenshot gives you an idea about the overview dashboard. Most important metrics are visualized. For example, the number of protected pods, the number of processed requests, the percentage of blocked requests, the license validity. This information is provided in numbers, but also as graphs. The different blocks which might occur in an environment is visualized within this dashboard. Filtering by namespace or block type allows to drill down and get a more detailed view. This is a starting point for any further investigation. Based on the logs, it is possible to filter easily for blocks that happened in your environment. You can filter by most important fields like pod, path, block type, attack type, details, client IP or request IP. This way you can investigate into the reason for this block and adjust the configuration as required. We have made some improvements in our OIDC relying party integration. Microgateway version 4.2 had the limitation that the ID token and access token are sent to the client in a cookie. These limitations are not ideal from security point of view and have been resolved in the new version. That is possible because a session store can be configured to save sensitive data. A new component, its name is Session Agent, takes care of saving and retrieving those data from Redis. The breaking change to version 4.2 is that persistency with Redis is required. Therefore, session handling must be configured. The OIDC configuration itself did not change. Further improvements for the OIDC integration are planned for future releases. The following picture shows the typical architecture of the Airlock Microgateway. With version 4.3, we introduced a session agent, which lives alongside of the engine container. An external Redis can be connected to the session agent and saves and retrieves data from it. The engine container connects to the session agent and gets and sets session data. The requests and responses are still processed as before. Transparently, the engine container persists the data through the session agent in Redis. The configuration steps are very simple. To enable session handling, reference a CR session handling in the CR sidecar gateway. In the CR session handling, reference a CR Redis provider, which defines how to connect to Redis. The current limitations of this setup is that the session agent only runs as sidecar. We have planned for a future release to deploy the session agent as an independent deployment outside the pod. For the moment, we do not support Redis cluster. It's also on our roadmap to make this feature available. Anyway, we would love to get feedback from you about the solution we provide, what features you miss, or what you like the most. Besides the big features I already mentioned, we made some other small improvements. It is now possible that gRPC can pass the Microgateway engine in the secure configuration. With the default log format, an external header can be configured for correlation, which is logged as an additional field in the logs. The limits CRD have been extended. Now the file upload size can be limited, and content type specific limits are available. There are some breaking changes in the release I like to mention. To simplify future extension, we changed a few engine metrics. The list shows the metrics in version 4.2 and the new metrics in version 4.3. As mentioned in the OIDC relying party improvements, with Microgateway 4.3 it is required to deploy a Redis and configure session handling. Let's have a look into the future of Microgateway. We have planned to extend the OIDC relying party integration with further features and make the experience even better. Additionally, we want to bring more Grafana dashboards to simplify the operation of Airlock Microgateway. In case that you miss an important feature, please reach out to us so we can discuss further details. I'd like to say thank you for your time and hope that you enjoy the new Microgateway release. Goodbye.